Hello, everybody. So today we're going to continue our discussion in Chapter 8, Section 1, and I'm going to talk about what a series is. As you may have learned in the last video, if you were able to watch that, we can have sequences that are either finite or infinite. And if we take those sequences and we add them up, we get something called a series. And the sum of those series is denoted by this Greek symbol right here, sigma. And sigma tells us that we should add up a certain number of terms from the sequence. There are infinite and finite series, and both actually can be added. And it might be a little bit strange to think about that you can actually add up an infinite number of numbers, but you can. I think I showed you in the previous video how to use your graphing calculator to do that. But for these infinite series, you will not be able to use your graphing calculator to add them up. You will actually need to be able to calculate partial of the series, a part of the series, and then use your recognition of patterns to see how this is going to work and be able to then write the sum of the infinite series. So let me show you how this works. So you can see right here for the first example, it says for the series sigma I equals 1 to infinity, 3 over 10 to the ith power. They want you to find the third partial sum and then the full sum. Now, the third partial sum, when you hear this word, third partial sum, what they want you to do is to find the first three terms of this series and then just add those up. So the way we would do that is we would start with our index here. The index is 1. And since the index starts with 1, we would put in 1 and get a number, put in 2 and get a number, put in 3 and get a number, and then add those three numbers up. So we'll go ahead and do that. So we'll start for the third partial sum. So this is part A. We'll have 3 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third power. Now, as I said, I did show you how to use these or to add these up using your calculator, but we're not going to do that. We're just going to stick with just using our brains instead. So 3 over 10, this is 3/10, and then this would be 3/100ths. And this would be 3/1000ths. Now, 3/10 is 0.3, 3/100ths is 0.03, and 3/1000ths is 0.003. So when we add those up, we end up with 0.333. That is called the third partial sum because we added up the first three terms. Now, for part B of this, they actually asked us to add up the entire thing. Now, you might say, well, it goes from 1 to infinity, so how are we going to add up an infinite number of numbers? Well, we don't actually have to do that. What we need to do is look at the pattern and see what's happening here. And you can see that each part adds another decimal place to it, and they keep getting smaller and smaller and smaller. And so if we were to continue this pattern, you'd see we'd have 0.3 plus 0.03 plus 0.003 plus 0.0003 and so on. And it would keep adding up. And what that would lead us to is getting a sum of 0.33333. On and on and on. And so what that actually equals is 0.3 repeating. Now, for 0.3 repeating, this is something that you probably should know. 0.3 repeating, the equivalent fraction of that is 1/3. So when you add those all up, you end up with 0.3 repeating, which turns into 1/3. Okay, so the next couple things I'm going to show you is there's a slide, and on your Google Classroom post, I will include these two links for you to be able to watch. But there are two slides here. Two links here. The first link is for a TI-84, and it shows you how to use your graphing calculator to evaluate a summation. The second link we have here is for a TI-83. If some of you are using those, you can use that. that link. One other thing that some people are not aware of is that you can update your TI-84s. Now, unfortunately, the 83s are not made anymore, so they're pretty obsolete as far as updating your operating system. But this video link right here is to show you how to update your TI-84 if you wish to do so. So that's what I have for you today, guys. As always, if you have any questions, feel free to email me. Have a great day.